Yes.
Good morning and welcome to the class.
Very
Very
good
good
morning.
morning.
So today we will have a brief discussion about the DR and the BDR election process in OSPF, our link state routing protocol. So here you can see a small schematic of 5 routers connected, 5 routers which are running OSPF connected to a broadcast network. It could be a LAN, Ethernet, and here you know that OSPF forms adjacencies with all its neighboring routers. So in a broadcast network, each and every router on that network is technically a neighbor. So you would have to form a full mesh of neighbor adjacencies. Since we have 5 routers here, about 10 adjacencies need to be formed. Each router forms an adjacency with all the other routers in the network. So if there are n routers in a network, then the number of adjacencies that is formed is n into n minus 1 by 2. So as the number of routers increases, this really multiplies and it creates a great overload on the network. And apart from this, the number of LSAs which need to be exchanged also grows exponentially. I believe that's around n square LSAs will need to be exchanged. So instead of that, OSPF proposes a hub and spoke topology for broadcast networks, where one router will be given the tag designated router, and all the other routers will only form an adjacency relationship with the designated router. Okay. So
Does this
what I'll do is
concept of DR is only in the broadcast network?
yes, in fact, it's available for broadcast multi-access networks like Ethernet, and also for non-broadcast multi-access networks like frame relay and AKIP, or other topologies like point-to-point and point-to-multipoint. We don't have the concept of DR or BDR. Okay.
Okay.
So what I'll do is I'll show you a small flow chart. Can you see this whiteboard?
Yes.
Okay. So what I'll do is I'll just we'll go through this in detail. Now here we have an election process going on for DR and BDR. When an OSPF router first becomes active on an network, it checks whether DR or BDR is available. It checks for DR and BDR. If it is available, then it accepts them. Otherwise, what it will do is it will go to the next step. It will start the election process. It will start an election process by exchanging hellos, and these hellos will contain the router ID, the router priority, and addresses of those interfaces which it thinks are the DR and the BDR. So when these hello packets are exchanged, then the router with the highest priority will become the BDR. Okay, the backup designated router. Then, if the priorities are equal, sometimes it may so happen that all. Yeah, tell me.
I have a doubt here. What is the default priority that is available on all the routers?
On Cisco, by default, the priority is 1. The priorities may range between 0 and 255. So, and if the router has a priority 0, then it can never become either the DR or the BDR. Okay. So then the priorities, if the priorities are equal, then the router with the highest router ID will become the BDR. Then it will check if there is no DR already available. If not, then the BDR becomes the DR. Okay. Then the process is started again, and we have an election for the